Welcome back to the Slow Almanac. Tonight, we are going out onto a wide salt flat at the edge of a high desert basin. There is almost nothing here. That is the point. Let your shoulders drop. Let your hands rest wherever they have fallen. If your eyes are open, let them close. There is nothing you need to see. Breathe in slowly. Hold it for a moment, then let it go. The flat stretches out in every direction, farther than you can follow with your eyes. It is white, not the white of paper or of paint, but a harder, older white, the white of mineral, of compressed time, of something that was once liquid and is now perfectly still. The surface catches the light and gives it back in a way that has no warmth in it. It is a clean, patient light. You are standing at the edge of the flat, where the pale crust meets the dark gravel of the basin's rim. Behind you, the land rises in low, dry ridges the color of rust and ash. In front of you, the flat goes on. It is perhaps 60 miles from one side of the basin to the other. You can see the far mountains from here, low, blue-gray shapes at the horizon, very far away, sitting at the edge of the sky, as though they have always been there and always will be. The air is thin. The basin sits high above sea level, high enough that the sky above you is a shade darker than you are used to, a deeper blue, the kind of blue that has less air between you and space. The sun, when it is up, is very direct. But right now the light is low and diffuse, the light of early morning or late afternoon, and it falls across the flat at a shallow angle, picking out the texture of the surface in long, soft shadows. The surface is not perfectly smooth. From a distance it looks smooth, the way a calm lake looks smooth from a distance. But you are close to it now, and you can see that it is not. It is divided into a vast mosaic of shallow polygons, hexagons and pentagons and irregular shapes, each one perhaps the width of a dining table, outlined by low ridges of salt no taller than your thumbnail. The ridges are slightly raised, slightly crumbled at their edges. They look like the cracks in old glaze on a piece of pottery, but they cover the whole plain, all the way to the horizon, as far as you can see in every direction. You step out onto the surface. It holds your weight without any give. It is hard underfoot, harder than packed earth, harder than gravel. It sounds faintly hollow, the way a wooden floor sounds hollow over an empty space below. That is because it is, in places. The crust is only a few inches thick, and beneath it, in the deeper layers, there are pockets of brine, water so saturated with dissolved minerals that it is almost a solid, almost a gel, moving with the slowness of something that has nearly stopped moving altogether. The crust is made mostly of salt, common salt, the same mineral that has been in every kitchen, on every table, in every preserved piece of food across all of human history. But here it is not a seasoning. Here it is geology. Here it is the record of a lake that was once enormous and is now gone, and left this behind. You walk a few paces out onto the flat and stop. You turn slowly. In every direction, the same pale surface, the same low ridges, the same distant mountains. There is almost no sound. The wind is very light, barely a breath, and it moves across the flat without catching on anything. There is nothing here to catch it. Somewhere beneath your feet, perhaps a meter down, perhaps 2, there is a layer of dark mud. Below that, another layer of salt. Below that, more mud, more salt, more mud, more salt. Alternating strata, each one a record of a different time, a different level of water, a different long evaporation. The flat you are standing on is not just a surface. It is a book. It is just written in a language that takes a very long time to read. Let me describe it again in a slightly different way. You are standing on a salt flat, a wide, pale mineral plain at the center of a high desert basin, ringed by dry mountains. The surface beneath your feet is hard white crust, divided into a mosaic of shallow polygons by low crystalline ridges. The sky above is a deep, dark blue. The air is thin and dry and very still. The flat is enormous. It takes up the whole floor of the basin. The basin itself is a closed basin, meaning that no river drains out of it. Whatever water comes in, whether from rain or snowmelt off the surrounding mountains, stays. It has nowhere to go but down into the ground or up into the air. In this climate, most of it goes up. The sun takes it. The dry wind takes it. The water evaporates, and what was dissolved in the water is left behind, layer by layer, year by year, millennium by millennium. The temperature on the flat changes by 40 degrees between noon and midnight. In the afternoon, the surface is hot enough that the air above it shimmers and bends the mountains at the horizon into slow, liquid shapes. At night, the temperature drops quickly, and the brine just beneath the surface contracts, and the crust shifts, and sometimes there is a faint sound, a low tick, a soft creak, as the salt adjusts. The flat is never entirely silent, but the sounds it makes are very quiet and very slow. The polygon shapes on the surface are made by this same process. During the day, the brine beneath the crust expands in the heat and pushes upward at the edges of each polygon, raising the ridges slightly. At night, it contracts and the ridges settle. Over many years, the polygons grow and stabilize into the shapes you see now, regular, patient, covering the whole plain. They are not carved or cut. They are grown. The flat made them itself, out of nothing but heat and cold, and the slow movement of saturated water. You sit down on the surface. It is hard and slightly gritty under your hands. The grains of salt are small and angular, and they leave a faint white dust on your palms. You brush them clean, and the dust falls back onto the flat, and the flat absorbs it without any change. The flat has absorbed a great deal over a very long time. The light falls across the polygons of its low angle, and each ridge casts a thin shadow. The whole surface is covered in these shadows, a faint grid of lines stretching away in every direction, and in this light, the flat looks almost like a map of itself, a vast, pale map of a place that is exactly where it is. In the still pools that collect in the lowest polygons after rain, the water is a pale pink or orange, tinted by the bacteria that live in brine too salty for almost anything else. The bacteria are the only living things that thrive here, in the water itself. They have been here longer than most things. They do not need much. They do not need anything that is not already here. You lean back on your hands. The surface holds you. The mountains sit at the horizon, the same distance away they have always been. The sky is very large. The story of how this flat came to be is the story of a lake that is no longer here. It is a long story, and it is still going on, and it began with water. Roughly 20,000 years ago, during the last great cold period of the current ice age, the climate in this basin was different, cooler, wetter. The mountains around the basin held glaciers, and the glaciers fed rivers, and the rivers fed a lake that covered the entire floor of the basin and more. A deep lake, cold and blue-gray, fed continuously by meltwater, holding perhaps 300 meters of water at its deepest point. The mountains you can see at the horizon were, for a long time, the shores of that lake. The flat you are sitting on was the bottom of it. The lake had no outlet. The basin was closed then, as it is now. Water came in from the mountain, and water evaporated from the surface. And for thousands of years, those two things were in rough balance. The lake stayed. It rose and fell with the seasons, rose and fell with the centuries, but it stayed. Then the climate began to shift, slowly. Over thousands of years, the temperature at this latitude rose. The glaciers in the mountains shrank. The rivers that fed the lake ran thinner. The rate of evaporation from the lake's surface stayed the same or increased because the air was warmer and drier. And so the balance tipped. More water was leaving than arriving. The lake began to fall. It did not fall quickly. It fell the way a lake falls when the climate changes. Not all at once, not in a rush, but in a slow, irregular retreat that took thousands of years and left marks on the landscape at every level. You can see those marks on the mountainsides around the basin if you know what to look for. Pale horizontal lines, faint terraces, old shorelines where the water once stood still, long enough to cut a ledge in the rock. Each line is a pause in the retreat, a century, perhaps several centuries, when the lake stabilized at that level before continuing to fall. As the lake fell, its water became more concentrated. There was less water, but the same amount of dissolved minerals, minerals that had been washing into the basin from the surrounding mountains for tens of thousands of years, carried in by rivers and deposited on the lake floor. As the water evaporated, those minerals had nowhere to go. They stayed. They concentrated. The lake became saltier year by year, decade by decade. At a certain concentration, the water can no longer hold all of its dissolved minerals in solution. The minerals begin to precipitate, to come out of the water and settle as solid crystals on the lake floor. Different minerals precipitate at different concentrations, in a predictable order. The least soluble ones come out first, when the water is only moderately concentrated. The most soluble ones come out last, when the water is nearly gone. Calcium carbonate came out first, a fine white powder settling slowly through the shrinking lake, building up on the floor in a pale layer. Then calcium sulfate, a slightly denser mineral, forming flat, translucent crystals on the sediment. Then, finally, as the lake shrank to a shallow brine pan, the common salt began to crystallize. It formed in crusts on the floor, and on any surface the brine touched, and it kept forming as the water continued to evaporate, layer upon layer, until the lake was gone, and the salt was all that remained. What you are sitting on is the last layer of that last evaporation. The crust beneath you is the residue of the final phase of a lake that took tens of thousands of years to fill and several thousand years to disappear. The whole history of that retreat is recorded in the layers below you, each layer a different mineral, a different concentration, a different moment in the long withdrawal of the water. The layers are not always continuous. In some places, a wet period returned, a few centuries of heavier rainfall, a partial refilling of the basin. The lake came back, shallowly. It dissolved some of the upper salt layers. It deposited new sediment on top. Then the dry period returned, and the lake retreated again, and new salt crystallized on top of the new sediment. The record is complicated. It has revisions, but it is all there, under your feet, waiting for someone with a drill and a great deal of patience to read it. The brine that still moves beneath the crust is what remains of the lake's water. It has been there for thousands of years, slowly sinking, slowly concentrating, slowly moving through the spaces between the salt crystals, the way groundwater moves through any porous rock, which is to say, very slowly, following pressure gradients so gentle that the movement is measured in meters per year, not per day. The brine is extraordinary. It contains, in solution, nearly everything the surrounding mountains are made of: sodium, chloride, magnesium, potassium, lithium, boron, dozens of other elements in trace amounts. The mountains have been dissolving into this basin for millions of years, and the water has been concentrating their minerals for thousands of years, and the result is a brine that is, in places, 10 times saltier than the ocean, a brine so dense that objects float in it without effort, a brine that is slowly, over geological time, becoming something almost too thick to flow. The lithium in the brine is worth mentioning, though only briefly. It is there in quantities that have drawn a great deal of attention in recent years, because lithium is useful for storing electrical energy, and the world has recently decided it needs a great deal of stored electrical energy. But the lithium has been in the brine for millions of years. It arrived the same way everything else arrived, dissolved out of the volcanic rock of the surrounding mountains by rainwater, carried down by rivers, deposited in the lake, concentrated by evaporation. It is just one more mineral in the record. The brine does not know it is valuable. The brine is not doing anything about it. The brine is simply there, moving very slowly through the dark beneath your feet. The layers themselves, if you could see them in cross-section, if you could cut straight down through the flat and look at the wall of it, the way you might look at the layers in a cliff face, would look something like this. At the top, the salt crust you are sitting on, white, hard, crystalline, perhaps 10 to 30 centimeters thick, depending on where in the basin you are standing. Below that, a layer of reddish-brown sediment, fine clay and silt, the color of old rust, deposited during a wetter period when the lake returned briefly and rivers brought in new material. Below that, another salt layer, older, slightly gray, packed more tightly than the upper one. Below that, more sediment, darker, almost black, organic material, the compressed remains of the bacteria and algae that lived in the ancient lake. Below that, more salt, more sediment, more salt. Each dark sediment layer is a wet period. Each pale salt layer is a dry one. The sequence goes down for perhaps 10 meters before you reach the bedrock of the basin floor, and in those 10 meters there are dozens of alternating layers, dozens of wet periods and dry periods, each one lasting centuries or millennia, each one faithfully recorded in the mineral chemistry of its layer. Scientists who study these cores, the long cylinders of sediment and salt drilled out of the flat, can read the layers the way a doctor reads a scan. The thickness of a layer tells you how long the wet or dry period lasted. The chemistry of the minerals tells you how concentrated the water was, and therefore how dry the climate was. The presence of certain microscopic organisms in the sediment layers tells you what the temperature was, because different organisms prefer different temperatures. The flat is an archive. It has been keeping records since long before anyone thought to ask. You press your palm flat against the surface. The salt is cool and slightly rough. Beneath your hand, beneath the crust, beneath the brine, beneath the layers of sediment and salt, the bedrock of the basin floor is the same volcanic and sedimentary rock that makes up the mountains around you. The basin itself is a structural depression. a place where the crust of the earth dropped along old fault lines, creating a bowl that the mountains drain into. The basin has been collecting water and minerals for millions of years. The flat you are sitting on is just the most recent deposit. In another 10,000 years, there will be more layers above this one, or there will not, depending on what the climate does, depending on how much water falls on the mountains, depending on things that are still being decided. Come back to where you are sitting. The flat, the wide, pale mineral plain, the mosaic of polygons stretching in every direction, the low mountains at the horizon, blue-gray and still, the sky, very large and very dark blue, the thin air, the quiet. You are sitting on the surface of the flat, your hands on the hard white crust, your weight held easily by tens of thousands of years of compressed mineral. The light is low. The shadows of the polygon ridges are long and soft. The wind is barely there, a breath across the surface, carrying nothing. Somewhere in the layers below you, there is a thin, dark band of sediment that was deposited at the bottom of the ancient lake, perhaps 15,000 years ago. At that moment, the lake was full. The water was cold and clear and deep. Fish may have lived in it. Small, pale fish adapted to cold and altitude. Water birds may have rested on it. The mountains around it were capped with ice that has since retreated. None of that is visible now. None of it left anything you could point to from where you are sitting. But it is there, in the record, a few meters below the surface. The flat does not miss the lake. The flat is not waiting for it to return. The flat is simply what the basin looks like now, in this particular moment of its long history. And it will look different in the future, and it looked different in the past, and none of those states is more correct than any other. The basin is doing what basins do. It is collecting what comes in and concentrating it and recording it without comment, without preference, without any particular interest in the outcome. If your mind has drifted, that is fine. There is nothing here that needs your attention. The flat will hold its shape without you watching it. The brine will move its slow millimeters through the dark without you thinking about it. The polygon ridges will expand and contract with the temperature, tonight, tomorrow, for the next 10,000 years, whether you are here or not. You don't have to keep track of anything. You don't have to remember the layers, or the chemistry, or the ancient lake. You can let all of that go. What remains is just this: the cool, hard surface beneath you, the wide, pale plain, the distant mountains, the dark blue sky, the thin air, the quiet. The light is fading now, or the light is already gone, depending on when you arrived here. In the dark, the flat is even more still. The polygon ridges disappear. The surface becomes a single unbroken pale shape, faintly luminous, holding the last of whatever light is in the sky. The mountains are dark outlines. The stars at this altitude are very bright and very many. The flat breathes in its way. The brine expands and contracts. The crust settles. A faint tick somewhere out in the dark as the salt adjusts to the cooling air. Then nothing. Then another tick far away in a different direction. The flat is doing its slow work. It has always been doing its slow work. It will keep doing it long after the night is over. You are very still. The flat is very still. The air between you and the mountains is very still. There is very little difference right now between you and the rest of the basin. Everything here is resting. Everything here is simply present, in the dark, in the thin air, on the pale surface of a place that has been here for a very long time, and will be here for a very long time more. Sleep well. The flat will be here when you wake up.